Moving on to theorems of moment of inertia, we have to deal with two theorems. One is theorem of parallel axis, another one is theorem of perpendicular axis. Let's talk about theorem of parallel axis. This states that, consider we have a rigid body which is rotating about this axis. Let the axis be AB. Okay. So moment of inertia about any axis of this body will be equal to moment of inertia of the same body about an axis passing through its center of mass. So we have to draw another axis which is passing from its center of mass. Let the axis be KL. So moment of inertia would be this moment of inertia KL plus the product of the total mass, which is basically the center of mass itself, because center of mass is where the whole mass of the body is concentrated. So product of this mass and the distance between these two axes. So this is the statement of theorem of parallel axis, that states that moment of inertia of a rigid body about any axis is equal to sum of moment of inertia about the same about the axis which is parallel to the given axis at some distance plus the mass of the whole body times the square of distance between the parallel axes. The only point to be noted here is this axis which is taken to the rotational axis. This axis has to pass through the center of mass. Okay. Now see the derivation. We have to prove it out. First of all, consider a general particle. Since this body comprises of n number of particles of various masses m1, m2, m3 at many other distances r1, r2, r3 and so on, we have considered just one particle. Let us say that particle be this. Let's say I am considering this particle which is ith particle, and distance from here to here would be this distance. Consider this distance to be ri, so this distance would be h plus ri. That is, the distance from KL is ri and from AB is h plus ri. Okay. Now moment of inertia about the axis KL would be summation I equal to 1 to n mi ri square. This is the general formula, and we have considered the ith particle to be here, so mi ri square. This is absolutely true. Now if I want to talk about moment of inertia about the same about the axis AB of the same particle which is ith particle, so it will be summation I equal to 1 to n mi, the distance of ith particle from AB is h plus ri, right? So the expansion of this thing will give me what? This will be equal to summation I equal to 1 to n mi times a square plus b square plus 2ab, right? I am opening up the summation format. It will be I equal to 1 to n mi h square plus summation I equal to 1 to n mi ri square plus summation mi 2h mi multiplied by ri, mi and ri. Now look at individual terms. First of all, this term here, h square is a constant, can be taken out. I am left with summation I equal to 1 to n mi. If I expand this term, I will get m1 plus m2 plus up to nth term, that is the total mass of the body. So this term will become total mass times h square. This is true. Number 2, let's talk about this term mi square. This is mi ri square. This is the moment of inertia about the axis KL. So I KL. Lastly, we are talking about this term which is summation 2h mi ri. Here the constant is, okay, so the constant is 2h. Taking out of summation psi, I am having 1 to n mi and ri. What is this? We are now talking about the moment of each particle about the center of mass, because suppose this particle, I am taking all these particles. So if this is the center of mass, the body is actually balanced about center of mass. So all these moments and all these moments are going to be equal, that is the clockwise moment will be equal to anti-clockwise moments. So sum of product of mass and distance, which is the moment of a particle, suppose m1, m2, m3, m4, m5, n6, m7 and m8, m1 r1 plus m2 r2 plus m3 r3, and here m5 m6 plus m7 m8, m7 r8, similarly like that. So the product of mass and distances of each on the anti-clockwise will be equal to product of mass and distance on the clockwise side. So that is why this mi/ri is equal to 0, because the body is balanced about center of mass and the moment of particle in clockwise and anti-clockwise direction would be equal. So that is why this term goes to 0. So what we are left with, only this much, and this is what the theorem of parallel axis states. So this is the proof of theorem of parallel axis.